In this question, we have to find the equation of the circle with center 0, 2 and radius 2. Let's begin with the solution. Here we are given the center of the circle, let us note it by C as 0, 2 and radius of the circle denoting it by R is equal to 2. We have to find the equation of a circle. Now we know that the equation of a circle with center HK and radius R is given by square root of x minus h whole square plus y minus k whole square is equal to R, where pxy is any point on the circle. So now let us find the equation of the circle with the help of this formula. Let pxy be any point on the circle of which we have to find the equation. Therefore, by the formula, it is given by square root of x minus h is 0 whole square plus y minus k is 2 here, 2 whole square is equal to R and R is 2. Now simplifying it further to get the equation of the circle, we have square root of x square plus y minus 2 whole square is equal to 2. Now squaring both the sides, on the left hand side we get x square plus y minus 2 whole square is equal to 2 square. This implies that x square plus y square minus 4y plus 4 is equal to 4. This implies that x square plus y square minus 4y is equal to 4 minus 4, taking this 4 on the right hand side. This implies that x square plus y square minus 4y is equal to 0. Therefore, the required equation of the circle with center 0, 2 and radius 2 is x square plus y square minus 4y is equal to 0. This completes the solution. In this question, we have to find the equation of the circle with center minus 2, 3 and radius 4. Let's begin with the solution. And we are given that center of the circle denoting it by C is minus 2, 3 and radius of the circle of which we have to find the equation is equal to 4. We have denoted the radius by R. We have to find the equation of the circle, and we know that equation of a circle with center HK and radius R is given by x minus h whole square plus y minus k whole square under the square root is equal to R, where pxy is any point on the circle. So, to find the equation of the circle with center minus 2, 3 and radius R, first let us suppose that P be a point with coordinates x, y on the circle. Now on comparing the center HK with the given center, we see that here in this case h is equal to minus 2 and k is equal to 3, and also The radius of the circle is equal to 4. Therefore, the equation of the circle is given by x minus of minus 2 whole square plus y minus 3 whole square is equal to 4. This implies that square root of x plus 2 whole square plus y minus 3 whole square is equal to 4. Now squaring both the sides, the root on the left hand side goes off and this becomes x plus 2 whole square plus y minus 3 whole square is equal to 4 square, which implies that x square plus 4x plus 4 plus y square minus 6y plus 9 is equal to 16. This further implies that x square plus y square plus 4x minus 6y. Now 9 plus 4 is 13. So plus 13 minus 16 is equal to 0. Or this is further equal to x square plus y square plus 4x minus 6y. Now 13 minus 16 is minus 3 is equal to 0. Therefore, the required equation of the circle with center minus 2, 3 and radius 4 is x square plus y square plus 4x minus 6y minus 3 is equal to 0. So this completes the solution. In this question, we have to find the equation of the circle with center 1 upon 2 and 1 upon 4 and the radius 1 upon 12. Let's begin with the solution. And here we are given a circle with center, let us note it by C, as half and 1 upon 4. And also we are given the radius, denoting it by a small r. So this is equal to 1 upon 12. This is given to us. Now we know that given a circle with center HK and radius of the circle R, the equation of the circle is given by square root of x minus h whole square plus y minus k whole square is equal to R, where x and y are coordinates of any point lying on the circle. Therefore, on comparing this, in this question, we have h is equal to half, k is equal to 1 upon 4 and r is equal to 1 upon 12. Now, let us find the equation of the circle which is given by square root of x minus h, that is x minus half whole square plus y minus k, that is y minus 1 upon 4 whole square is equal to 1 upon 12. Now, on squaring both the sides, we have on the left hand side x minus half whole square plus y minus 1 upon 4 whole square is equal to 1 upon 12 whole square is 1 upon 144. Now this further implies, on opening the brackets, we have x square minus x plus 1 upon 4 plus y square minus half y plus 1 upon 16, and taking this on the left hand side we have minus 1 upon 144 is equal to 0. Now this implies x square plus y square minus x minus half y. Then now simplifying the constants, we have 1 upon 4 plus 1 upon 16 minus 1 upon 144 is equal to 0. This further implies that x square plus y square minus x minus half y plus, now the LCM of the denominators of the three term is 144. Now 4 into 36 is 144, so in the numerator we have 36 plus, now 16 into 9 gives 144 and 9 ones are 9, so 9 in the numerator minus 1 is equal to 0. So this implies that x square plus y square minus x minus half y plus, now on simplifying the numerator we get 44 and in the denominator we have 144. This is equal to 0. Now 4 11s are 44 and 4 into 36 gives 144. So multiplying the equation by 36, this implies that 36x square plus 36y square minus 36x minus 36 upon 2 into y plus 11 is equal to 0. Now 2 into 18 is 36, therefore this is the required equation of the circle. Therefore our answer is the equation of the circle with center having coordinates half and 1 upon 4 and the radius 1 upon 12 is 36x square plus 36y square minus 36x minus 18y plus 11 is equal to 0. So this completes the solution. In this question, we have to find the equation of the circle with center having coordinates 1, 1 and radius square root of 2. Let's begin with the solution. And here we are given a circle with center having coordinates 1, 1 and radius, let us note it by small r, equal to square root of 2. Now we know that given a circle with center having coordinates hk and radius r, the equation of the circle is given by square root of x minus h whole square plus y minus k whole square is equal to r, where x and y are the coordinates of any point P lying on the circle, right? So comparing this with the given data, we find here that the value of h is 1, k is 1 and r is equal to square root of 2. Therefore, the equation of the circle is given by x minus 1 whole square plus y minus 1 whole square is equal to root over 2. Now, to get rid of the square root sign, we will square both the sides. We have x minus 1 whole square plus y minus 1 whole square is equal to 2. Now opening the brackets, this further implies that x square minus 2x plus 1 plus y square minus 2y plus 1 is equal to 2. This further implies that x square plus y square minus 2x minus 2y plus 2, and taking this 2 on the left hand side. Now this further implies that we have x square plus y square minus 2x minus 2y is equal to 0, since plus 2 and minus 2 cancels out. Therefore, the required equation of the circle with center having coordinates 1, 1 and radius root over 2 is x square plus y square minus 2x minus 2y is equal to 0. This completes the solution. In this question, we have to find the equation of the circle with center having coordinates minus a minus b and radius square root of a square minus b square. Let's begin with the solution. And here we are given a circle with center having coordinates minus a minus b and radius, let us denote it by small r, is equal to square root of a square minus b square. We have to find the equation of the circle. Now, we know that in a circle with center having coordinates hk and radius r, the equation of the circle is given by square root of x minus h whole square plus y minus k whole square is equal to r, where x and y are the coordinates of a point P lying on the circle. Now, comparing this with the given data, we see that the value of h is minus a and the value of k is minus b. So here, h is equal to minus a and k is equal to minus b and the radius r is equal to square root of a square minus b square. And also let P be any point on the circle. Now the equation of the circle we know is equal to square root of x minus of minus a whole square, since we have x minus h whole square and h is minus a, plus y minus of minus b whole square is equal to r, which is square root of a square minus b square. So this implies that x plus a whole square plus y plus b whole square is equal to a square minus b square. Here we have squared both the sides and therefore we have x plus a whole square plus y plus b whole square is equal to a square minus b square. Now let us proceed further. Now, opening the brackets, we have x square plus 2ax plus a square plus y square plus 2by plus b square is equal to a square minus b square. Now a square on both the sides cancels out. So we have x square plus y square plus 2ax plus 2by plus b square, and taking this minus b square on the left hand side we have plus b square. This is equal to 0. So this further implies x square plus y square plus 2ax plus 2by plus 2b square is equal to 0. Therefore, the equation of the circle with center minus a minus b and radius square root of a square minus b square is x square plus y square plus 2ax plus 2by plus 2b square is equal to 0. This completes the solution. In this question, we have to find the center and the radius of the circle whose equation is given to us as x plus 5 whole square plus y minus 3 whole square is equal to 36. Let's begin with the solution. And we know that if equation of the circle is of the form x minus h whole square plus y minus k whole square is equal to r square, then the center of the circle has coordinates h and k, and the radius of the circle is equal to r. Now let us see the given equation. The given equation is x plus 5 whole square plus y minus 3 whole square is equal to 36, or this can further be written as x minus of minus 5 whole square plus y minus 3 whole square is equal to 6 square. Now let us denote the standard form of the equation of a circle as 1 and this as 2. Now on comparing equation 1 and equation 2, we see that the value of h is minus 5 and the value of k is 3. So we have h is equal to minus 5 and k is equal to 3. Also r is equal to 6. So the radius of the circle r is 6. Therefore our answer is center of the circle, whose equation is given to us, is minus 5, 3 and radius is equal to 6. This completes the solution. In this question, we have to find the center and the radius of the circle, whose equation is x square plus y square minus 4x minus 8y minus 45 is equal to 0. Let's begin with the solution. And we know that if equation of the circle is of the form x minus h whole square plus y minus k whole square is equal to r square, then center of the circle is hk, that is the coordinates of the center of the circle are h and k, and radius is equal to r. Therefore, we will try to write the given equation in the standard form. Let us denote the standard form of the equation by equation number 1. Now, the given equation is x square plus y square minus 4x minus 8y minus 45 is equal to 0. This implies that x square minus 4x plus y square minus 8y minus 45 is equal to 0. Now, completing the squares within the parenthesis, we get x square minus 4x plus 4 plus y square minus 8y plus 16 is equal to, taking this 45 on the right hand side. Now we have added 4 and 16, therefore adding them on the right hand side also. Now this further implies that this can be written as x minus 2 whole square, since on expanding we get x square minus 4x plus 4. Similarly, this can be written as y minus 4 whole square, and this is equal to 65. Now let us denote this equation by equation number 2. Now let us compare this equation by the standard form of the equation of a circle. We see that h is equal to 2 k is equal to 4, right? And here see that on the right hand side we have r square, so we have to write 65 in the form of its square. So it can be written as root over 65 whole square. Therefore, r is equal to root over 65. Thus our answer is the center of the circle whose equation is given to us is 2, 4 and its radius is square root of 65. This completes the solution. In this question, we have to find the center and radius of the circle given to us, which is x square plus y square minus 8x plus 10y minus 12 is equal to 0. Let's begin with the solution. And the given equation of the circle is x square plus y square minus 8x plus 10y minus 12 is equal to 0. Now, completing the squares within the parenthesis, the given equation of the circle can further be written as x square minus 8x plus y square plus 10y is equal to 12. Now we will complete the squares of these two brackets, that is, this can be written as x square minus 8x plus 16. So adding 16 on the right hand side since we have added it on the left hand side, and this bracket can be written as y square plus 10y plus 25. Now adding 25 on the right hand side since we have added it on the left hand side. This further implies that now this can be written as x minus 4 whole square. The second bracket can be written as y plus 5 whole square, and on adding 12, 16 and 25 we get 53. Now we know that for standard form of the equation of a circle of the type x minus h whole square plus y minus k whole square is equal to r square, the center has coordinates h and k and the radius is r. So from this equation, let us denote this equation by 1. So from 1 we get, let us first try to write it in the form of the standard equation of a circle. So this can be written as x minus 4 whole square plus we have y plus 5 whole square. So it can be written as y minus of minus 5 whole square is equal to r square, and 53 can be written as square root of 53 whole square. Now on comparing these two equations, we see that h is equal to 4 and k is equal to minus 5 and r is equal to square root of 53. Therefore, the given circle has center at 4, minus 5 and the radius is square root of 53. This completes the solution. In this question, we have to find the center and radius of the circle whose equation is 2x square plus 2y square minus x is equal to 0. Let's begin with the solution. And we know that if equation of a circle is of the form x minus h whole square plus y minus k whole square is equal to r square, then center has coordinates h and k and the radius of the circle is given by r. Now, the given equation is 2x square plus 2y square minus x is equal to 0. Now dividing both the sides by 2, we have x square plus y square minus 1 upon 2 into x is equal to 0. Now this further implies that x square minus half x plus y square is equal to 0. Now completing the squares within the parenthesis, we get x minus 1 upon 4 whole square plus y minus 0 whole square is equal to, now on expanding the first bracket we see that we have x square minus 1 upon 2 into x plus 1 upon 16. So to equate the both sides, we write 1 upon 16 on the right hand side. So this further implies that x minus 1 upon 4 whole square plus y minus 0 whole square is equal to 1 upon 4 whole square. Now let us denote the standard form of the equation of the circle by equation number 1 and this equation by equation number 2. Now on comparing equations 1 and 2, we see that h is equal to 1 upon 4, k is equal to 0 and r is again equal to 1 upon 4. Therefore our answer is the required center of the circle, whose equation is given to us, has coordinates 1 upon 4 and 0 and radius equal to 1 upon 4. This completes the solution. In this question, we have to find the equation of the circle passing through the points having coordinates 4, 1 and 6, 5 and whose center is on the line 4x plus y is equal to 16. Let's begin with the solution. Now, let C be the center with coordinates h and k and r be the radius of the given circle. Then the equation of the circle will be x minus h whole square plus y minus k whole square is equal to r square. So this is the equation of the circle with center having coordinates hk and r as its radius. Now we are given that the circle passes through the points having coordinates 4, 1 and 6, 5. Therefore, here we have 4 minus h whole square plus 1 minus k whole square is equal to r square. And now the circle also passes through the point having coordinates 6, 5. Therefore, replacing x by 6 and y by 5, we have 6 minus h whole square plus 5 minus k whole square is equal to r square. Now we see that the right hand side of both the equations are equal. Therefore, equating the left hand sides, we have 4 minus h whole square plus 1 minus k whole square is equal to 6 minus h whole square plus 5 minus k whole square. So this implies 16 minus 8h plus h square plus 1 minus 2k plus k square is equal to 36 minus 12h plus h square plus 25 minus 10k plus k square. Now h square from both the sides cancels out. Similarly, k square from both the sides cancels out. Now taking rest of the terms on the same side we have. Now bringing minus 12h to the left hand side gives plus 12h, and 12h minus 8h is 4h. Now we have minus 2k here, and on the right hand side we have minus 10k. Now bringing it on the left hand side gives plus 10k, and subtracting 2k from it gives plus 8k. Now 16 plus 1 is 17, and on the right hand side we have 36 plus 25, which is equal to 61. So this implies 4h plus 8k is equal to 44. Taking 17 on the right hand side, let us denote this equation by 1. Now we are also given that the center is on the line 4x plus y is equal to 16. Now since the center is on the line 4x plus y is equal to 16, therefore replacing x by h and y by k, since the coordinates of the center are h and k, this implies that 4h plus k is equal to 16. Let us denote this by equation number 2. This implies that k is equal to 16 minus 4h. Now substituting the value of k, (16 minus 4h) in equation number 1, we get 4h plus 8 into k, and k is 16 minus 4h is equal to, on the right hand side we have 44. So this implies 4h plus 128 minus 32h is equal to 44. Now this implies that minus 28h is equal to 44 minus 128. So this implies h is equal to, now 44 minus 128 is minus 84, and cross multiplying we have minus 28 in the denominator. Now cancelling the negative sign, 7 4s are 28, and 7 into 12 gives 84. 4 3s are 12. This implies that h is equal to 3. Now substituting h is equal to 3 in k is equal to 16 minus 4h. So this implies that k is equal to 16 minus 4 into 3, that is 16 minus 12, which is equal to 4. Therefore k is equal to 4. Now substituting the value of h and k in any one of these two equations. So let us substitute the value of h and k in this equation. So this is the equation in which we have to substitute the value of h and k. So this implies 4 minus 3 whole square plus 1 minus 4 whole square is equal to r square, which implies that r square is equal to 1 square plus minus 3 whole square, that is 9, which is equal to 10. Therefore r is equal to square root of 10. Therefore the equation of the circle is x minus h whole square, and h is 3, plus y minus k whole square, and k is 4, is equal to r square, that is 10. So this can further be written as x square minus 6x plus 9 plus y square minus 8y plus 16 is equal to 10, or this can be written as x square plus y square minus 6x minus 8y 9 plus 16 is 25. Taking this on the right hand side, we get 10 minus 25, or this can be written as x square plus y square minus 6x minus 8y, and on simplifying the right hand side we get minus 15. Bringing on the left hand side we get plus 15 is equal to 0. Therefore, the required equation is x square plus y square minus 6x minus 8y plus 15 is equal to 0. This completes the solution. In this question, we have to find the equation of the circle passing through the points with coordinates 2, 3 and minus 1, 1, and whose center is on the line x minus 3y minus 11 is equal to 0. Let's begin with the solution. And we know that the equation of the circle with center having coordinates h and k and radius r is x minus h whole square plus y minus k whole square is equal to r square, where x and y are the coordinates of any point P on the circle. Now, we are given that the circle is passing through the points with coordinates 2, 3 and minus 1, 1. Therefore, replacing x by 2 and y by 3 in the equation of the circle, we get this equation denoting this by 1. Now, minus 1, 1 also satisfies the equation. Therefore, we have minus 1 minus h whole square plus 1 minus k whole square is equal to r square, denoting this by equation number 2. Now, as we can see, the right hand sides of both the equations are same, therefore their left hand sides are also equal. So we have 2 minus h whole square plus 3 minus k whole square is equal to minus 1 minus h whole square plus 1 minus k whole square. Now opening the brackets and simplifying, this can further be written as 4 minus 4h plus h square plus 9 minus 6k plus k square is equal to 1 plus 2h plus h square plus 1 minus 2k plus k square. Now h square on both the sides cancels out, k square on both the sides cancels out, and now taking all the terms having variables on one side and constants on the other. So we have 6h plus 4k is equal to 13 minus 2, that is 11, denoting this by equation number 3. Now the question further says that the equation of the circle has its center on the line x minus 3y minus 11 is equal to 0. And since the center hk is on the line x minus 3y minus 11 is equal to 0, therefore this will also satisfy the given equation. Therefore, we have h minus 3k is equal to 11, denoting this by equation number 4. Now this implies that h is equal to 3k plus 11. Let us denote this by equation number 5. Now substituting, h is equal to 3k plus 11 in equation number 3, which is 6h plus 4k is equal to 11. So we have 6 into 3k plus 11 plus 4k is equal to 11, or this further implies 18k plus 66 plus 4k is equal to 11, or we have 22k is equal to 11 minus 66, or 22k is equal to minus 55, Or we have k is equal to minus 55 divided by 22. So we have 11 2s are 22 and 11 5s are 55. So we have minus 5 upon 2, the value of k. Now h is equal to 3k plus 11. Therefore, h is equal to 3 into minus 5 upon 2 plus 11. So this is equal to minus 15 upon 2 plus 11, which is equal to minus 15 plus 22 whole divided by 2, which is equal to 7 upon 2. Therefore, we have k is equal to minus 5 upon 2 and h is equal to 7 upon 2. Now, let us substitute the value of h and k in the equation 1 to get the value of r. So this implies 2 minus h whole square plus 3 minus of minus 5 by 2 whole square is equal to r square, and thus we got, on substituting, the values of h and k in equation 1. Now this further implies that now we have minus 3 upon 2 whole square on simplifying the first bracket plus 3 plus 5 upon 2, which gives 11 upon 2 whole square. So this is equal to r square. So this implies r square is equal to 9 upon 4 plus 121 upon 4, which is equal to 130 upon 4. And on simplifying we get 2 2s are 4, 2 6 are 12, 2 5s are 10. This implies that r square is equal to 65 upon 2. Now we have got the value of r square, h and k. Therefore, the equation of the circle is x minus h whole square, and h is 7 upon 2 plus y minus k whole square. So y minus of minus 5 upon 2 whole square, and minus minus is plus. So we have y plus 5 upon 2 whole square is equal to r square, which is 65 upon 2. Now let us open the brackets. So this can be written as x square minus 7x plus 49 divided by 4 plus y square plus 5y plus 25 divided by 4 is equal to 65 divided by 2, or this is equal to x square plus y square minus 7x plus 5y plus 49 divided by 4 plus 25 divided by 4 minus 65 divided by 2 is equal to 0. Or we have x square plus y square minus 7x plus 5y minus 56 divided by 4, which is equal to x square plus y square minus 7x plus 5y minus 14 is equal to 0. Therefore, the required equation of the circle is x square plus y square minus 7x plus 5y minus 14 is equal to 0. This completes the solution. In this question, we have to find the equation of the circle whose radius is 5 and center lies on the x-axis and passes through the point having coordinates 2 and 3. Let's begin with the solution. Now we know that the equation of the circle with center having coordinates h and k and radius 5 is given by x minus h whole square plus y minus k whole square is equal to 5 square, or x minus h whole square plus y minus k whole square is equal to 25. Let us denote this by equation number 1. Now we are given that the center of the circle lies on the x-axis. So let the center be, now since it lies on the x-axis, therefore y coordinate is 0. Therefore here k is equal to 0 and the center is CH0. So equation 1 implies that x minus h whole square plus y square is equal to 25. Now also we are given that the circle passes through the point having coordinates 2, 3. Therefore, this point will satisfy the equation, that is, replacing x by 2 and y by 3, we have 2 minus h whole square plus 3 square is equal to 25. So this implies that 4 minus 4h plus h square is equal to 25, and taking this 3 square on the right hand side we have 25 minus 9, which is equal to 16. So this further implies that h square minus 4h minus 12 is equal to 0. Now let us simplify this equation to get the values of h. Now splitting the middle term, this can be written as h square minus 6h plus 2h minus 12 is equal to 0. Taking h common from the first two terms and 2 common from the last two terms, this can further be written as h into h minus 6 plus 2 into h minus 6 is equal to 0. So this implies h plus 2 is equal to 0, or h minus 6 is equal to 0. So this implies that h is equal to minus 2 or 6. So here we have two values of h. Therefore, we can get two equations of the circle. Case 1, when h is equal to minus 2, k is 0 and r is equal to 5, then the equation of the circle is x minus of minus 2, that is x plus 2 whole square, plus y minus 0 whole square is equal to 5 square, or this can be written as x square plus 4x plus 4 plus y square is equal to 25, or this can be written as x square plus y square plus 4x minus 21 is equal to 0. So this is the first equation of the circle. Now let us consider case 2, when h is equal to 6, the values of k and r remain the same. Therefore we have x minus h, that is x minus 6 whole square, plus y minus 0 whole square is equal to r square, that is 25. So we have x square minus 12x plus 36 plus y square is equal to 25, or we have x square plus y square minus 12x plus 36 minus 25 is 11, so 11 is equal to 0. Therefore, this is the second equation of the circle. Hence our answer are the equation of the circle are, in the first case we got x square plus y square plus 4x minus 21 is equal to 0 and x square plus y square minus 12x plus 11 is equal to 0. This completes the solution. In this question, we have to find the equation of the circle passing through the point 0, 0 and making intercepts A and B on the coordinate axis. Let's begin with the solution, and first let us draw the figure from the given data. Suppose this is the figure such that the circle passes through the point 0, 0 and makes intercept A with the x-axis and B with the y-axis. So this point will be A0, that is this point, and this point will be 0P. Let us denote this point by A and this point by B. Therefore, we can say the points A with coordinates A0 and B with coordinates 0B lie on the circle, and also as we can see from the figure, if the point of intersection of the coordinate axis, let us denote it by O, then angle AOB is equal to 90 degrees. This implies that if we join the line AB, then AB is the diameter to the circle. Therefore, using the diameter form, the equation of the circle is x minus A into x minus 0 plus y minus 0 into y minus b. So this is equal to 0. This on simplifying gives x square minus ax plus y square minus yb is equal to 0, which further implies that x square plus y square minus ax minus by is equal to 0. So this is the required equation of the circle which passes through the point 0, 0 and which make intercept A and B on the coordinate axis. This completes the solution. In this question, we have to find the equation of the circle with center having coordinates 2, 2 and passing through the point 4 and 5. Let's begin with the solution. The equation of the circle with center having coordinates hk and radius r is given by x minus h whole square plus y minus k whole square is equal to r square. Now here the center has coordinates 2, 2. Therefore, we are given that h is equal to 2 and k is equal to 2. So this implies the standard form of the equation can be written as x minus 2 whole square plus y minus 2 whole square is equal to r square. Now, as we are also given that the equation of the circle is passing through the point 4, 5. Now the circle passes through 4, 5. This implies that 4 minus 2 whole square plus 5 minus 2 whole square is equal to r square. Since in the standard form of the equation of the circle, x and y are the coordinates of any point from which the circle is passing. So this implies 2 square plus 3 square is equal to r square, or r square is equal to 4 plus 9, which is equal to 13. Therefore, the equation of the circle is x minus 2 whole square plus y minus 2 whole square is equal to r square, and r square is 13. Now this can be simplified further, or x square minus 4x plus 4 plus y square minus 4y plus 4 is equal to 13. This further implies that x square plus y square minus 4x minus 4y. Now 4 plus 4 is 8, and 13 minus 8 is 5. Therefore, the required equation of the circle is x square plus y square minus 4x minus 4y is equal to 5. This completes the solution. In this question, we are given the equation of a circle x square plus y square is equal to 25, and we have to find whether the point with coordinates minus 2.5 and 3.5 lie inside, outside, or on the circle. Let's begin with the solution. Now, the given equation is x square plus y square is equal to 25, or this can be written as x minus 0 whole square plus y minus 0 whole square is equal to 5 square. Now we know that this implies that the center, denoting it by C, of the circle is 0, 0, and radius of the circle is 5, since we know that if equation of a circle is x minus h whole square plus y minus k whole square is equal to r square, then the center has coordinates h and k, and the radius of the circle is given by r. Now, let us denote the given point by P. So let P with coordinates minus 2.5 and 3.5 be the given point. Now we will find the distance of point C and point P. If this distance will be less than the radius, then the point will lie inside. If it will be greater than the radius, then the point will lie outside. And if the distance is equal to 5, then it will lie on the circle. So first let us find CP with the help of distance formula, which is square root of minus 2.5 minus 0 whole square plus 3.5 minus 0 whole square. So this is equal to square root of, here we get minus 2.5 whole square, which is 6.25, plus 3.5 whole square is 12.25. So this is equal to square root of 18.50, which is less than 5. Since 5 square is 25 and 18.50 is less than 25, therefore the distance of point C and P is less than the radius. Therefore, the given point with coordinates minus 2.5 and 3.5 lie inside the circle. This completes the solution.